Forces in motion. How can you describe motion? Types of motion. You are moving all the time. You walk around your school. You stand up from your chair. You roll over in bed. Your heart beats and your eyelids blink. Motion is also all around you. Different things move at different rates. A sea star moves very slowly. It may seem as though it is not moving at all. An airplane propeller moves so quickly that you can't even see its blades. The motion of a sea star is very slow. There are many different types of motion. Earth is in constant motion. It is always moving as it travels around the sun. Cars, trucks, and buses have variable motion. They can move in many directions. They can also change their speed. A pendulum has periodic motion. It swings back and forth when it moves. A rubber band has vibrational motion. It vibrates when you pluck it. The train has variable motion. It can speed up or slow down. Speed and velocity. Average speed tells how far an object moves in a certain amount of time. This is the formula for average speed. Speed equals distance divided by time. Are you in motion when you sit in a chair? You are not moving in relation to the chair, but you are moving in relation to the sun. You and Earth are moving around the sun faster than a rocket. To measure motion, you need to look at an object's position when compared to a location. This location is called a point of reference. Speed changes with the point of reference you use. For example, a woman walking inside of a moving train is moving slowly. The train is moving very quickly. Her motion measured in relation to the end of the train car is one speed. Her speed in relation to a crossing gate next to the tracks is another. Let's use the end of the train as a point of reference. If the woman walks 10 meters through the train in 5 seconds, she has a walking speed of 2 meters per second. Now let's use the crossing gate as a new point of reference. Suppose the train is going 30 meters per second. The woman is still walking at the same rate. But with the gate at a point of reference, she is moving about as fast as a train is. So her speed is about 30 meters per second. Sometimes knowing the speed of an object is not enough. Velocity is the speed of an object in motion and its direction. The speed of the train is 30 meters per second. Its velocity is 30 meters per second north. A skydiver might have a velocity of 200 kilometers per hour downward. What are forces? Pushes and pulls. A force is a push or pull that acts on an object. A force can make an object speed up, slow down, or change its direction. Forces have magnitude and direction. The magnitude of a force is how strong the force is. It is measured in units called newtons. N. The direction of a force tells which way the force is pushing or pulling. If you hold an apple on your hand, it exerts a downward force with a magnitude of about 1 newton. Gravity. Every object in the universe pulls on every other one. This pull is called gravity. But only the gravity of a large object such as Earth is strong enough to be felt. Earth's gravity pulls all objects toward it without even touching them. Pendulums swing, apples fall, and satellites stay in orbit because of the pull of Earth's gravity. An apple falls because gravity pulls it downward. Gravity makes the velocity of the apple increase as it falls. Weight is the amount of gravitational force between an object and Earth. It depends on the mass of the object and the Earth's mass. It also depends on how far above Earth the object is. You weigh a bit less when you fly in an airplane high above Earth. Your weight would be different on other planets. This is because other planets have different masses, so they pull with different amounts of gravitational force. The chart shows how much an object weighs 100 newtons on Earth would weigh on other planets. Planet and weight in newtons. Earth is 100, Mercury 38, Venus 91, Mars 38, and Jupiter 253. Gravity is what makes a pendulum swing downward. The pendulum then swings upward until gravity stops it. Then, as gravity pulls it back down, it swings in the other direction. Magnetism and electricity. Magnetism is a force that pushes and pulls objects. The force is strongest at the poles of a magnet. All magnets have a north pole and a south pole. Magnets pull strongly on objects made of iron, cobalt, and nickel. The force of a magnet also works on other magnets. The north pole of one magnet will attract or pull on the south pole of another. Two poles that are the same will push each other away. Electric forces act between objects that have electrical charges. All atoms have electrons, which are negatively charged, and protons, which are positively charged. An object is negatively charged if it gains electrons. It is positively charged if it loses electrons. If you rub silk and glass together, electrons move from the glass to the silk. This gives the glass a positive charge and the silk a negative charge. All objects with electrical charges push or pull on each other. It is similar to the way magnets work. Objects with opposite charges pull toward each other. Objects with the same charge push away from each other. The force of the magnet pulls bits of iron toward it. Gravity, electricity, and magnetism. Magnetic and electric forces can act even if the objects do not touch. All these forces get stronger as the objects get closer to each other. Gravity is different from electricity and magnetism in two important ways. First, you can block the forces of magnetism and electricity. All you have to do is put certain kind of metals between the objects. But you cannot block gravity. And the second difference is that the direction that the forces work. Electricity and magnetism can push or pull on objects. Gravity can only pull on objects. The magnetic field of this stone attracts the metal pins to its surface. Friction. Friction is the force that results when two materials rub against each other. This force can slow the motion of an object or keep it from moving. Friction depends on the objects that rub together. The shape, speed, or texture of one object can affect the amount of friction with another object. The texture of your socks let you slide across a smooth floor, but the texture of your shoes do not. There is more friction when you try to slide in your shoes. Air and water resist motion when moving objects push against them. Air or water flowing over a surface causes friction. Cars and airplanes are designed to cause little friction with the air. Submarines and ships are designed to cause little friction with the water. The shark's shape and its spinal skin reduce its friction with water. Special skin, my apologies. This helps the shark to swim smoothly and swiftly. Work and power. Work has a special meaning in science. Work is the energy when a force moves on an object. If an object does not move, no work is done. Work is calculated by multiplying the force used to move an object by the distance the object is moved. Work equals force multiplied by distance. Work is measured in units called joules. 1 joule is the amount of work done when a force of 1 Newton moves an object a distance of 1 meter. Power is the rate at which work is done. Power is increased when work is done faster. Walking and running up a hill take the same amount of work, but running up the hill is faster, so it takes more power. Power is measured in newtons called watts. To compute power, divide the amount of work done by the amount of time it takes to do the work. Power equals work divided by time. Holding the ball takes force, but work is done only when a force moves an object. Since the ball does not move, no work is being done. What are Newton's laws of motion? Sir Isaac Newton, born 1642 and died in 1727, was one of the world's most important scientists. His work led to 3 laws that explain why objects move as they do. Net forces. Many forces can act on an object at once. They may act in many different directions, and some may be stronger than others. The combined forces on an object is the net force. The net force controls whether the object will start moving, stop moving, or change its direction. Forces can be balanced. This occurs when equal forces act on an object in opposite directions. When this happens, the net force is 0. An object in a state of equilibrium, when all forces acting on it balance each other. A moving object in equilibrium keeps moving at a constant speed in a straight line. A motionless object in equilibrium will not start to move. The 5 Newton force and the 10 Newton force add up to a net force of 15 newtons. 10N, 5N, net force 15N. Unbalanced forces can make an object change its motion. Forces are out of balance if the forces acting in one direction are greater than the forces acting in another. If 2 people push on a box from opposite directions with the same amount of force, the box will not move. But if one person pushes with more force than the other, the forces are unbalanced. There is a net force in the direction of the stronger push. The box moves in that direction. Balanced forces push against the box. There is no net force. The box does not move. Unbalanced forces push against the box. There is a net force in the direction of the stronger force. The box moves in that direction. A jet moves in a straight line at a constant speed, but forces are acting on it. Drag pushes against the jet's forward motion. Drag slows it down. Thrust pushes the jet forward. Lift pushes the jet up against the downward pull of gravity. Newton's first law. Newton's first law of motion says that an object will stay in constant motion until a net force acts upon it. An object at rest will stay at rest until a net force moves it. An object moving in a constant speed will keep moving in a straight line at that speed. If a net force acts upon it, it can change speed or direction. Objects tend to resist any change in motion. This is known as inertia. Objects with greater mass have more inertia than objects with less mass. Your body's inertia is what pushes you against the side of a car as it goes around a curve. Your body tends to keep moving in a straight line. Then the car turns. It takes a moment for the motion of your body to adjust. A full truck has more inertia than an empty truck. It will take more effort to make the heavy truck stop or speed up. A space probe is an example of Newton's first law. Inertia keeps the probe moving through space. Probes need very little fuel after they get into space. There is no net force to slow them down. They usually need fuel only to change direction in order to slow down. Inertia will keep the football moving after the kick. Eventually, the gravity will pull the ball back to the ground. The football stays at rest on the tee until the force of the kick causes it to move.